So, like Ravida mentioned, I am a scientist by profession, and more specifically, a chemist. So, I'm going to talk about like how I discovered my passion for chemistry, and then how I ended up working on artificial cells, and what I want to do for the future, and a few specific things on the current pandemic situation. So the way we go through different stages of our career and education is very similar to how a multi-stage rocket functions. Now, in the early stage, we need an enormous amount of thrust to get us going. And then once we discover like what we like and what we want to do in our life, we don't need that much thrust and push. And finally, in the later stages, just a little bit of push is sufficient to put us into the track and leads us to the destiny. So my journey started in the 90s. I grew up in West Bengal, and my family consists of my parents and my younger sister. I went to Ramakrishna Mission Vidyalaya Narendrapur. It is a school which is built on the ideals of Swami Vivekananda, specifically the idea of holistic learning, which means equal emphasis was given on the conventional education as well as character building. Our school was fully residential. So we stayed with our classmates in hostels 24/7, and we had to do everything from studying to gardening by ourselves. So that was a great training to be self-reliant and independent from a very young age. My school played a very important role in my upbringing, and it also helped me to discover my passion for chemistry. So in our school, we had chemistry as a separate subject from class 8 onward. Now I remember that when we first started chemistry, most of my friends and peers, they were very scared of it because we had to memorize many big formulas and long chemical equations. I mean, I was good at it, but I was not quite getting the big picture behind studying all of those things. So I decided to go to our college library and figure out like what chemistry is all about. So one day I went to the library and I picked up a thick organic chemistry book. And I found that that book was full of really long formulas like this. And in the class, like we were already struggling with long formulas like potassium ferrocyanide or ammonium phosphomolybdate. And it didn't make sense to me, like how can people remember these long formulas and balance the equations? And then I picked up another book which was lying next to it, and it was a biochemistry book. And I found that the formulas and structures there are just crazier. And I felt like these must be the worst subjects in the world. But sometimes, we do have a curiosity about things about which we have a very negative first impression. So that day, I ended up issuing the biochemistry book, and I took it back home. So when I first started reading this book, I realized it's about something that I have never read or known before. It was about how life functions. I read about how amino acids join together and make these things called proteins, and how these proteins fold into unique three-dimensional shapes, and some of them function as catalysts, and some of them make tiny machines. I learned about how carbohydrates are broken down inside our body and how that generates energy, or how lipids self-assemble to form the protective barriers of the cells. And all these scary looking big formulas, they were nothing but a very specific language. And if you know how to read that language, you can read the language of life. So I went back to the library, I picked up more books, and I really got engrossed into this new world. And I realized that this was what I was truly passionate about. Then there was another event during my school life, which had a big impact for me. And I wish that these kind of things happen more often for school students. So we were once taken to a visit to the Indian Institute of Chemical Biology. And that was the first time I saw a research lab. I saw this big fancy instruments and these bottles of chemicals with the names of which I just read in books, but I never saw them before. And the whole environment seemed magical to me, like a kid taken to a huge toy store. And also in our school, we had some amazing teachers in chemistry who I would say were one of their own kind. So together, I was like finding a lot of motivation to study chemistry and take this as my future career. But in spite of all this excitement and fun, I had to go through a little bit of uneasy phase. So I don't know how things are right now, but when we were students, it was quite a default choice to either go for engineering or for MBBS, kind of like what you see in the Three Idiots movie. And I used to be the topper of my class, and so there was a lot of expectation from me, from my peers or my teachers and everyone else around to take all these entrance exams and secure some good ranks. And I was preparing for those exams as well because I wanted to keep all options open. But what happened is that I ended up securing the top rank in my state medical entrance exam. And then I was in a little bit of confusion, like, should I just leave this and pursue my passion for chemistry, or should I just go with the MBBS? So I did I had to do a lot of critical thinking. And finally, I came to a state where I found a truce between my brain and my heart. And I convinced myself that this was not just some teenage romance. I really like to study chemistry, and if I don't do it now, then probably later I won't have another chance to go back at it. So in the end, I decided to go for the integrated master's program at IIT Kharagpur. Now, looking back at this time, I sometimes feel that like it should have been easier for me or maybe someone in my position to understand like what qualities should decide whether someone should go for chemistry or not. And also, it's a bit less well-defined compared to like the aptitudes of math, physics, or computer programming, where if people are good, they just simply know it. So I came up with a list defining the different qualities that can define this sort of chemistry aptitude. So first of all, you have to keep in mind that chemistry is vast. It's about diversity and multitudes of things. I mean, there are 3 elementary particles in chemistry and 94 natural elements, 20 proteinogenic amino acids, 5 common nucleobases, and everything else in chemistry is practically uncountable. So you have to deal with this vastness of number, and you have to dive into that and enjoy that enormousness. And also, chemistry is the central science. It draws from physics and applies into biology and different engineering subjects. So if someone is good at all of these different subjects and enjoys them to a certain extent, then they should be considering chemistry as their career. Then chemistry is about building materials that do not exist. So one has to be very creative about it. And chemistry is very hands-on. Like, you have to work with many different instruments and chemicals, and you have to improvise with the tools and techniques. So you really need to have a knack of working with different kinds of things. Then it involves a lot of uh, keen observation and curiosity about things that surround us. And finally, um, chemistry is a lot about connecting the dots and playing detective. So you have to be very intuitive. Like in chemistry, not always 2 and 2 equals 4. It can be 3.9, it can be 4.1. So you have to accommodate those kind of thinkings in yourself. And if you have these things, then I'll say that you should definitely choose chemistry as your career. Now, I have a few of my own suggestions that can be implemented in schools, especially because of the new education policy that was implemented in India, that was proposed in India last year. And I believe if some of these things can be incorporated in our curriculum, it will just help accentuate this chemistry aptitude in school students. So first of all, chemistry and also biology, they're very dynamic subjects. I mean, new knowledge is created every year, and a lot of things change within a span of just 15 to 20 years. So I think if many archaic things can be removed from our syllabuses and it's made more fitting for the current state of knowledge, then that will create more interest in the people. And like I mentioned earlier, that chemistry is a very hands-on subject. So the more opportunity of some hands-on workshops or at least exposure to science labs or research labs are given to the students, the more interest they will find, and they will find a good relation between what they read in textbooks versus what happens in real world. Okay. So for my college, I went to IIT Kharagpur, and the IITs are a great place of learning, not just curriculum-wise, but to develop someone in terms of an individual capability due to many reasons. The IITs are very reputed global brands, so if you're from one of them, then it becomes much easier to get recognized in later stages of life. The curriculum is highly multidisciplinary, and there is a lot of flexibility in terms of what kind of courses you can take. And we were taught by professors who are actively doing research. So it's a very different kind of experience learning from them. And then the campus life used to be very vibrant, and there was a strong entrepreneurial culture. And there was another thing which I really appreciated about the IITs, and that was the 3-month summer vacation. And this long summer vacation meant that like we had plenty of time to pursue an internship in an industry or academia. So in the first 2 years of my undergraduate, I went to IISc and JNCSR for summer internships through the KVPY program. And this program also played a very important role in my academic journey, because it provided all these opportunities of internship, and there were many other outreach programs that used to happen. Now, during the 3rd year of my undergraduate, a very important event in my life happened, and that's exactly the reason why I'm here today. So I was selected as a Corona program, which started 3 or 4 years before that. And I was placed into the University of Minnesota for 2.5 month internship. So that was the first time I was going outside of India and meeting all these new people, exploring this new culture. And that was one of the best experiences in my life. I mean, I felt like I grew some wings. And I'm really thankful to like all the people who were behind this Corona program. It really had a transformational effect in our lives. And I'm very proud, and I'm very happy to be a part of this Corona and SNBOS scholars community. And then in the next year, I wanted to experience a bit of the research and education in Europe. So I applied to Ecole Polytechnique through its own internship program. And that was also a very unique kind of experience for me. So by this time, through all these different kind of research and educational experiences, I knew that I wanted to pursue a PhD, and most likely I wanted to be in academia in the future. So during my college, I read one book called Who Wants to Be a Scientist? And this book really helped me to streamline my thoughts and provided me a lot of clarity about different things. So this is one of my favorite quote from this book. It says that one doesn't need to be terrifically brainy to become a scientist. So this is actually very true and often quite misunderstood. I mean, a lot of people think that one needs to have a 160 IQ to become a scientist. I mean, it's great, but it's not necessary. I think the most important quality to be a good scientist is to be very hardworking and to have a lot of mental strength to deal with the failures that come on the way. So if you're in master stage or in early stages of your PhD, I highly recommend that you read this book. Now, this is a very important thing before applying for PhD programs. And it's not necessary to know exactly what you want to do research on, but it really helps if you have some kind of like innate passion for something or some question that you already have in your mind from much earlier age. So thankfully, I had one such question in my mind since when I was in school. So when I was in school, while I was doing this exploration of different aspects of chemistry, I happened to read about a very fascinating science experiment. Now, this experiment was done by a 21-year-old scientist named Stanley Miller. So he was a PhD student back then, and he was working under the Nobel laureate Harold Urey at the University of Chicago. So he was working on a very interesting question. Like, he wanted to know how life started on Earth. But it's a very difficult thing to approach because we cannot go back in time and figure out like how life started on Earth. So what Stanley Miller did was very clever. He simulated the conditions that may have existed on a primitive Earth inside a lab. So he built this special apparatus and filled it with some gases which were likely present in the atmosphere of a primitive Earth. And then he passed electricity through that to mimic the effects of lightning and thunder. And then by doing that, he got a mixture of amino acids and many other organic compounds that serve as the building blocks of life. Now, like reading this experiment, like I thought that like if the building blocks of life can be made literally out of thin air, then is it possible to trace back all the steps that led to the emergence of life in the first place? Now, when I was like thinking and rethinking about all these things, I came to know about another emerging branch of science, which is very much related to these kind of things. So that area of science is known as synthetic biology. And what it aims to do is to make an artificial cell. Now, what is an artificial cell? I mean, when I first read about this, I was like, I thought it was science fiction. And probably many of you here also haven't heard or known much about it. So conceptually, artificial cell is some entity or some construct which is built from purely non-living building blocks and something that shows some of the basic features of living organisms. Now, what is the motivation behind building this? The main motivation behind building this is to understand like what is the minimal recipe for life, like what are the minimum number of things you need to put together to call something as living. So it's a very fundamental question. There are many practical aspects as well, which I'll talk about later, but this is the main question, like what is the minimum number of things that you need to put together to call something as living? So this is a very interesting and thought-provoking question, and I came across a lab of Professor Neil Devraj at University of California, San Diego. And so he was a new faculty at that time, and he just started working on this fantastic question. So I applied there, and I got selected to this lab. And over the next 6 years or so, I had the privilege of working with a very dynamic scientist like Dr. Devraj. So my research was to build some simple biomolecular systems from very basic building blocks like lipids and proteins and sugars, and show some very basic life-like features such as compartmentalization and metabolic reactions, growth and division. So during my PhD, I built a few artificial cellular systems, which includes some artificial cell membranes and artificial organelles that mimic endoplasmic reticulum of cells. So that was a very interesting journey, and I defended my PhD in March of 2020. I was very lucky because my defense was the last public defense of our department. And I'm really glad that I didn't miss that opportunity. So after that, I continued for a few months in the same lab. And from September, I moved to Stanford University. And here I'm working on a somewhat related problem, but in a different direction. So right now I'm working on understanding how infectious viruses interact with biological membranes. So I'm looking at the physical mechanisms which drive those kind of things. And you can imagine it's a very relevant problem now, given the current pandemic. So after this, academia is a very difficult area. I don't know if you know that probably less than 10% of the people who start end up becoming professors. So I don't know for certain that where I will be in the next 5 years or so, but let's see. But what I really want to do is to continue with teaching and research in the future. So I have this passion for teaching, likely from my father, who is a teacher and who is a very compassionate and sincere teacher. My mother is not a teacher by profession, but she is very much a strict teacher. And I have been fortunate to be taught by many fantastic teachers throughout my life. So I think that this is something which can have a great impact on a social level. And I also want to do some science communication and science writing, both of which can also have great impact on the society. And by the way, these two are good emerging careers in science, and these are something I will also recommend you to look at, especially if you are good at writing and if you have good speaking skills. Okay, so for the remaining time, I will talk on a slightly different topic, which is relevant to the current pandemic and what lessons we can take from here. So you might have heard this phrase, the Great Reset. This is a phrase that's being used to describe the pandemic because it's going to change the way we study, the way we work, the way we travel, the way we socialize from now onwards, and at least for the upcoming 5 to 10 years. And I'm sure, like many of you here, that you have experienced a lot of inconveniences, especially those of who you are students in schools and colleges. And I feel very sorry for you. I don't know how you are dealing with this, but just remember that what doesn't kill you makes you stronger. So I'm sure you will come back strongly after all of this is over. Now, if anything we learned from this pandemic is that the role of science and technology in our daily lives and how it can help us sustain our civilization. So if we prepare ourselves in a very scientific minded way, then probably we can avoid or at least mitigate future catastrophic events like this in a more planned way. And this has to be done not only on an individual level, but also on a government level, on a policy level. So we know that like our in India, our government's response was reasonably good, and like thanks to all of our healthcare workers and scientists and all other frontline workers, uh, we managed to deal with the pandemic in a quite good way. And if we can continue working on that, like building on our experiences in certain way, then it's definitely going to uh, make us more prepared for any future such happenings. So I'm going to talk about a few research areas which I think needs to be promoted better, and which can help us to deal with some of these future things. So one area that I mentioned a bit earlier is synthetic biology. Now, what is synthetic biology? Synthetic biology, it basically means creating new biology. Now, you can think of it in a, like conceptually, you can think of it very similar to synthetic chemistry. Now, what we do in synthetic chemistry, we make new materials using things that we find from nature. Now, you must have read the Haber's process in your schools. So what is done there? We take nitrogen, we take hydrogen, and we take some catalyst, and we make ammonia. Now, where do these things come from? I mean, nitrogen comes from atmosphere, hydrogen comes from petroleum or natural gas, and iron comes from rocks from earth. So when we bring all these things together, we get something which doesn't exist like that in nature. And this whole process, this is completely artificial. There is nothing like that, or at least like mechanistically, nothing like that taking place in nature. So in synthetic biology, what we want to do is that we want to take these different parts and pieces from different places in nature. Like we can take something from, let's say, fungi and something from an algae, and put them together and make something like a biosensor or a biocomputer. Now, these things are still all on the drawing board, and the possibilities are pretty much endless. So this is where a lot of creativity can be expressed. So I think for people who are like thinking of pursuing a new kind of research direction, this is a field that I will highly recommend you to look at. And then thanks to the advancements in genome technologies like CRISPR, which I'm sure you have heard, it was awarded the Nobel Prize last year. So that has enormous promises to enhance and modify the existing biology and create new biological functionalities. And finally, the grand challenge of synthetic biology is making of artificial cells from scratch. And we don't know what can be done with artificial cells. Probably we can make artificial red blood cells or artificial stem cells or artificial cells that kill viruses. So many disciplines are going to come here together, like physics, chemistry, engineering, and putting all these things together, we can do like huge developments for the future. So the next field which needs a lot of emphasis is structural biology. Now, the reason why we were able to understand about coronaviruses and get a vaccine so soon is due to tremendous advancement in structural biological techniques like cryo-electron microscopy, X-ray crystallography, and nuclear magnetic resonance. Now, structural biology, in spite of their names, involves a lot of physics and mathematics and computation and chemistry. And it is a field which is very challenging, and it's not for the faint of the heart or the brain. But if you like to take on challenges, this is a great field, and the rewards are really big, like Nobel Prize big. Like just to give an example, like Venkatraman Ramakrishna, the Indian Nobel laureate, who got the Nobel Prize for discovering the structure of ribosome, was a structural biologist, and great impact can be made by doing fundamental research in this field. And then like we had this huge global catastrophe because of the virus, but probably the next big catastrophe is going to come from environmental disasters. So if we don't prepare ourselves for those situations, then our future is not going to look great. So sustainable development should be a priority. And this is, again, another field where people from many different expertises and backgrounds should come together and find out innovative solutions to prepare us better for the future. And finally, we are already at the doorsteps of the next big industrial revolution, where algorithms will be the engine and data will be the new oil. Yes, it's a artificial intelligence revolution, and it's an all-pervading force right now. Even in chemistry, people are using AI to design drugs and optimize reaction like processes and doing retrosynthesis. And AI is going to be a part of healthcare monitoring and learning and all sorts of things. So yeah, our Indian government is currently quite well prepared. It ranked 40 out of 171 countries in AI Readiness Index, but we have to be better at that and invest a lot of infrastructure and funding in there. And finally, one thing that I just want to mention quickly here is that, so I said that this pandemic helped us realize the importance of science on a government and policy level. So what we need more in India is to have leaders from science and education background, like people who are scientists or scholars. So these are the kind of leaders we need many more. And right now, the representation of scientists and PhD holders in cabinet or like the various constitutional posts is really low, not just in India, but in every country. So we definitely need to think of improving that and lead our society through knowledge and innovation. So with this, I will share a few pearls of wisdom that I picked up on the way. And I just want to say that we need to, or you should get over something called the placement attitude. Like it's, by which I mean that, like we often think of an accomplishment by looking at how much salary we earn or the rankings of the universities that we go to, but that often doesn't reflect our true passion. So it's more important to follow our passion and be at the place where we can make an impact. Then I just want to highlight a few things that you should take very seriously, like being fit and healthy, both physically and mentally. Communication is another great important skill that to master, both in terms of interpersonal levels and with the society, especially on things like science and the importance of it. You can see that misinformation is a big problem in our times. I mean, we have a lot of ways to spread information. That means there are a lot of ways to spread misinformation as well. And then whatever we do in our life is because of sacrifice and contributions made by a lot of people. So we should be grateful towards all of them and try to give back something to them. And lastly, on a bit of light note, this is my favorite meme. Like, do not believe in everything that you see on the internet. So please use the internet, but please use it responsibly. And here are like a few, I put together a few things that I think might be helpful for you. Like, I didn't do all of these things myself, but I think that if you can do some of these things, it will be of huge help for you. And I'm on Twitter, so if you want to connect with me, you can message me there. And yeah, so thank you very much. Thank you for being here today. And I would like to take a few questions.